In previous videos at the Santorini Passive House, which is where we are now, we talked a lot about mold, water infiltration, and rats. Well, today we're going to talk a little bit about what that water infiltration does to us, not just with respect to mold, but what it does to the structure of the house itself. Now, we can see here that this is a corner that's seen a lot of water infiltration, and it's seen a lot of water infiltration because the roofing was done really incorrectly. But what we see here is a lot of different things. We see mold on the backside of the drywall. Now that's really common. Drywall is essentially a paper-backed material of talc or gypsum. And that water on that paper causes the mold to grow really, really quickly. But it also causes mold to grow on the wood itself. But one of the things that's really impactful on these structures is that water goes into that wood, soaks up some of those chemicals, and then leaks into the ground. And what we see is that when we get water infiltration, especially from roof and plumbing leaks, we see termites migrating up out of the ground. They basically have tunnels under the ground. In this area, we have subterranean termites. They sense that water with that wood smell, and they follow it up into the structure. And here we see that the termites have actually had a field day, and we can literally take apart parts of this wood and see their trails. Right here in this big structural beam that supports this whole window, we see termites that have just gone along the length of the wood, eating all of the softwood between the growth rings. You can literally see pathways through this beam. This stud right here and all this corner are all rotted out, partially from termites, but also partially from just rot. And in fact, what we see is we have rot on top of the termite mounds. So the termites have made better ways for the water to get in and cause this whole thing to just crumble, right? It's just a horrible waste of a big structure. We have a lot of places where we have water that's come across and it's hit the nails. Now, the nails on these structures are required because we're an earthquake country, and these nails hold these buildings together, and specifically they hold the plywood or the shear walls onto the structure of the building, giving it its lateral resistance. So when an earthquake comes, if the house doesn't shift with the earthquake, with the ground, the house will fall down like a house of cards. The problem is that when water hits these nails, it starts rusting them. And if it rusts the nails and reduces the shank size, meaning the diameter of the shank of the nail, it reduces the structural integrity of this plywood. We could get plywood that literally fails because it's no longer attached to the wood or the house itself. And lastly, wood causes rot, but it also causes collapse. And what we showed in our previous video is that when the wood loses enough strength to support its own weight and the weight of the building above it, it starts to shrink. That causes cracks, that causes jammed windows and doors, that causes all kinds of problems. And often that's the first way that we determine if a house is starting to structurally fail. This house structurally failed during deconstruction. This house was really at the very end of its lifetime, and that's why you see we're having to remove so much of this structure. If you're interested in learning more about building science, hit subscribe as we show you how to build a better way.